The Megamouth Shark. Off the coast of Hawaii, a research vessel accidentally caught something in 1976 that shouldn't have been possible. A shark, 15 feet long, weighing over 1,600 pounds, and completely unknown to science. This wasn't some tiny hidden species lurking in a cave. This was a massive, filter-feeding shark cruising the open ocean, and somehow, despite centuries of marine research, nobody had ever documented one. The megamouth has a bulbous head, a mouth nearly 4 feet wide, and rows of tiny, non-functional teeth. It feeds by swimming with its enormous mouth open, filtering plankton and jellyfish from the water. What terrified scientists wasn't just the size. It was the realization that an animal this large, living in relatively accessible waters, had remained completely invisible to humanity until the late 20th century. The discovery shattered assumptions about how well we understood the ocean. If a 15-foot shark could hide in plain sight, what else was down there? Since that first specimen, fewer than 100 megamouth sharks have ever been observed. It's still one of the rarest sharks on Earth, and the fact that it took us this long to find it is a reminder that the ocean doesn't give up its secrets easily. Dumbo Octopus. This lives deeper than any other octopus on the planet, at depths where the pressure would crush a car into the size of a soda can. The Dumbo octopus gets its name from the ear-like fins on the sides of its head that flap when it swims, making it look like it's flying through the water. It's small, usually around 8 inches long, and it hovers just above the seafloor at depths of up to 13,000 feet. That's over 2 miles down. At that depth, there's no light, almost no oxygen, and the cold is so extreme that most life forms can't survive. But the Dumbo octopus isn't just surviving, it's thriving. When scientists first discovered these creatures in the late 1800s, they couldn't understand how an octopus, a group of animals typically found in shallower coastal waters, could exist in such a hostile environment. The Dumbo octopus doesn't have an ink sac like most octopuses, because there's no point in releasing a cloud of ink when there's no light for predators to see it. Instead, it's adapted to life in near total darkness by developing highly sensitive skin and fins that let it sense even the faintest movements in the water. The discovery forced scientists to rethink the limits of where complex life could exist. If an octopus could live at the bottom of the ocean, what other assumptions about deep-sea biology were wrong? Vampire squid. The name alone is enough to make you uncomfortable, and the appearance doesn't help. This thing looks like it was designed by someone who'd never seen a normal sea creature and was told to make something as unsettling as possible. The vampire squid has a gelatinous body, massive blue eyes, and 8 arms connected by webbing that looks like a cloak. When threatened, it pulls that webbing over itself and flips inside out, revealing rows of fleshy spines. It's called a vampire squid, but here's the thing, it's not actually a squid. It's not an octopus either. It's something else entirely. A living relic from a time when the ocean was a very different place. Scientists classify it in its own unique order, Vampiromorphida, because it doesn't fit neatly into any existing category. The vampire squid lives in oxygen minimum zones, regions of the ocean where oxygen levels are so low that most animals would suffocate. These zones exist at depths of around 2,000 to 3,000 feet, where the water is cold, dark, and nearly lifeless. When scientists first discovered the vampire squid in 1899, they couldn't understand how anything could survive in such an environment. The answer turned out to be a metabolism so slow, it's almost undetectable. The vampire squid doesn't hunt. It drifts through the water, feeding on marine snow, tiny particles of dead organic matter that sink from the surface. It's been doing this for over 300 million years, which means it predates the dinosaurs and has barely changed since. The discovery challenged everything scientists thought they knew about predator-prey dynamics in the deep sea. And down here, normal stopped applying a long time ago. Barreleye fish. Imagine a fish with a completely transparent head. Not translucent, transparent. You can see straight through its skull to its brain, its eyes, and the fluid-filled dome that protects them. The barreleye fish was first discovered in 1939, But for 70 years, scientists had no idea how it actually worked. Every specimen they brought to the surface was dead or damaged, and the delicate transparent dome over its head would collapse under the pressure change. It wasn't until 2009 that researchers finally observed a living barreleye in its natural habitat, using remotely operated vehicles. What they found was so strange, it forced them to rewrite their understanding of fish vision. The barreleye's eyes are tubular, not spherical like most fish. They point straight up, locked in place, scanning the water above for the silhouettes of prey. But here's the part that baffled scientists. How does a fish with eyes that only point upward catch anything in front of it? The answer is that transparent dome. Inside the dome, the eyes can rotate. When the barreleye spots prey above, it tilts its entire body upward, and its eyes rotate forward to track the target as it moves in for the kill. The discovery revealed a level of anatomical complexity that nobody expected from a deep-sea fish. The barreleye lives at depths of around 2,000 feet, where even the faintest amount of sunlight struggles to penetrate. Its eyes are so sensitive, they can detect bioluminescence from other creatures, which it uses to hunt in near total darkness. The transparent head protects its eyes from the stinging cells of jellyfish, which make up a significant portion of its diet. Scientists had been studying this fish for decades, and it took advanced technology and luck to finally understand how it survived. Giant isopod. If you've ever seen a pill bug, the little armored creature that rolls into a ball when you touch it, you know what an isopod looks like. Now imagine that same creature, but the size of a football. That's the giant isopod, and when scientists first pulled one up from the deep sea in 1879, they were genuinely disturbed. This thing weighs up to 3.5 pounds, and can grow over 16 inches long, which makes it one of the largest members of the crustacean family. It's got 14 legs, compound eyes, and a segmented exoskeleton that looks like medieval armor. The giant isopod is a scavenger, feeding on dead whales, fish, and squid that sink to the ocean floor. It can survive for years, possibly even decades, without eating. One specimen in a Japanese aquarium went 5 years without food before it died, and scientists still don't fully understand how its metabolism works. What terrified researchers wasn't just the size, it was the implication. Deep-sea gigantism is a real phenomenon, and the giant isopod is one of its most extreme examples. On land, arthropods, the group that includes insects and crustaceans, are limited in size by the way they breathe and the constraints of gravity. But in the deep sea, where the pressure is immense and the cold slows metabolism, things get big. The discovery of the giant isopod challenged assumptions about the limits of arthropod size and raised uncomfortable questions about what else might be lurking at depths we haven't fully explored. To put that in perspective, this is a pill bug that weighs more than a house cat, and it's thriving in an environment where most life forms would be crushed instantly. By the way, if you're finding this dive into the deep sea as fascinating as I do, I post content like this regularly. I'd appreciate it if you subscribed. Thanks, Anglerfish Discovery. In the early 1900s, when deep-sea trawls started bringing up specimens from the abyss, scientists kept finding these small, bizarre fish with enormous teeth and bioluminescent lures dangling from their heads. Female anglerfish. But something was deeply wrong. Every single female they examined had strange, fleshy growths attached to her body. Parasites, they assumed. Except when they studied the growths more closely, they realized these weren't parasites at all. They were males. Tiny, degenerate males that had fused permanently to the female's body. Their circulatory systems merged, their organs reduced to nothing but testes. The male anglerfish bites into the female's skin and releases an enzyme that dissolves the tissue, fusing them together at the cellular level. Over time, the male's eyes degenerate, his internal organs shrink, and he becomes nothing more than a sperm-producing appendage. The female can carry multiple males on her body at once, a living harem of parasitic mates. When this reproductive strategy was first documented in the 1920s, scientists were horrified. This wasn't just unusual mating behavior, this was biological nightmare fuel. The discovery forced researchers to completely rethink sexual dimorphism and reproductive strategies in extreme environments. In the deep sea, where finding a mate in total darkness is nearly impossible, evolution came up with a solution so disturbing it still shocks people today. The male gives up everything, his independence, his organs, his identity, just to reproduce. And down here, that's considered normal. Gulper eel. This one doesn't look like an eel. It looks like a mouth with a tail attached. The gulper eel's mouth is massive, far larger than its entire body, and it can unhinge its jaw to swallow prey that's bigger than itself. When scientists first discovered it in the mid-1800s, they couldn't understand how an animal with such an extreme adaptation could function. The gulper eel lives at depths of up to 10,000 feet, where food is scarce and encounters with prey are rare. Its entire body is built around a single strategy: eat whatever you find, no matter the size. The mouth can expand to engulf fish, squid, and crustaceans that would normally be too large for a predator of its size. After swallowing, the eel's stomach stretches to accommodate the meal, and its slow metabolism allows it to survive for weeks or even months without eating again. What made scientists rethink deep-sea predation wasn't just the jaw, it was the tail. The gulper eel has a long, whip-like tail tipped with a bioluminescent organ. Researchers believe it uses this light to lure prey, though the exact mechanism is still debated. The discovery revealed that deep-sea predators had evolved strategies far more extreme than anything seen in shallow waters. The gulper eel doesn't chase its prey. It doesn't need to. It drifts through the water with its mouth open, waiting for something to swim too close. And when it does, the entire encounter is over in seconds. Frilled shark. This thing is a living fossil, and when fishermen first hauled one up in the late 1800s, they thought they'd caught a sea serpent. The frilled shark looks like it was pulled straight out of the age of dinosaurs, and in a way, it was. It's barely changed in 80 million years. The frilled shark has a long, eel-like body, 6 pairs of gill slits that ripple along its neck, and a mouth filled with 300 needle-sharp teeth arranged in 25 rows. Each tooth is designed to snag and hold on to slippery prey like squid and fish. When it bites, there's no escape. The teeth angle backward, so anything caught in its jaws is pulled deeper into its mouth with every struggle. Scientists were baffled when they first studied the frilled shark because it didn't fit into any existing category of known sharks. Its anatomy was too primitive, its hunting methods too strange. It hunts by ambush, lurking in the deep and striking with a sudden lunge that's more like a snake than a shark. The frilled shark lives at depths of up to 5,000 feet, and it's rarely seen. Most specimens are found by accident, either caught in fishing nets or washed ashore after dying. Contrary to what most people think, the frilled shark almost never encounters humans, and the few interactions that have occurred were purely accidental. It's not hunting us. It's hunting in a world where we don't belong. The discovery forced scientists to confront the reality that the deep sea is home to creatures that evolution forgot to update. And honestly, that's more unsettling than any modern predator. Tube worms. In 1977, scientists exploring hydrothermal vents near the Galapagos Islands found something that shouldn't have been able to exist. Massive tube worms, some over 8 feet long, clustered around volcanic vents on the ocean floor at depths of over 7,000 feet. The environment was toxic, superheated water reaching temperatures of over 700 degrees Fahrenheit, mixed with chemicals like hydrogen sulfide that would kill most life instantly. And yet, these worms weren't just surviving, they were thriving in massive colonies. The discovery terrified scientists because it violated one of biology's most fundamental rules. All complex life on Earth depends on photosynthesis. Plants use sunlight to create energy, animals eat plants or other animals, and the entire food chain traces back to the sun. Except these tube worms had no access to sunlight. They lived in total darkness, miles below the surface, in an environment so hostile, it resembled the surface of another planet. The answer to how they survived rewrote biology textbooks. The tube worms have no mouth, no digestive system, and no way to eat. Instead, they harbor bacteria inside their bodies that convert the toxic chemicals spewing from the vents into energy through a process called chemosynthesis. The worms and the bacteria exist in symbiosis, each one dependent on the other for survival. This was the first time scientists had ever discovered an entire ecosystem that didn't rely on the sun. The implications were staggering. If life could exist in such extreme conditions on Earth, it could exist in similar environments elsewhere in the universe. Hydrothermal vents on the moons of Jupiter and Saturn suddenly became viable candidates for extraterrestrial life. And even by deep sea standards, this discovery was revolutionary. Goblin Shark. When Japanese fishermen started pulling up this nightmare in the late 1800s, they didn't know what they were looking at. The Goblin Shark has a long, flat, blade-like snout that extends far beyond its mouth, giving it an alien profile unlike any other shark. But the real horror is the jaw. When the Goblin Shark attacks, its jaws shoot forward out of its mouth, extending several inches to snag prey in a lightning-fast strike. The entire skull is built around this mechanism, with specialized ligaments and cartilage that allow the jaw to unhinge and project outward, like something from a science fiction movie. Scientists were disturbed when they first dissected a goblin shark and realized how its anatomy worked. This wasn't just an unusual predator. This was a shark that had evolved a feeding mechanism so extreme it challenged everything they knew about vertebrate jaw structure. The goblin shark lives at depths of up to 4,000 feet, where the pressure is crushing and prey is scarce. Its skin is translucent, giving it a pinkish color from the blood vessels visible underneath. That snout isn't just for show. It's packed with electroreceptors that detect the faint electrical signals given off by prey in the darkness. The goblin shark drifts through the water, snout scanning like radar, and when it detects something edible, those jaws explode forward. The discovery forced scientists to rethink the limits of predatory adaptation. Evolution doesn't just tweak existing structures. Sometimes it redesigns them completely. If this sparked your curiosity about what's really lurking in the deep, consider subscribing so you don't miss future ocean content. Thanks for watching.